Let's just see the first distribution, the first continuous distribution, which is the uniform distribution. It says that given any range, maybe in between A to B, okay, given any range, let's suppose you are having in between A to B, you are having a non-zero PDF, sorry, yeah, non-zero PDF. Yeah, this is PDF, which is a probability density function. It says that in between A to B, you are having non-zero, and let's suppose for every other value, which is zero, okay, for every other value, which is zero. Now, if you draw the samples from this kind of distribution, that from A to B it is non-zero, every other value will be from zero, then your data points will be in between A to B only, right? I mean, since the probability of having something here is zero itself, here is zero itself, because the PDF is zero, then probability is zero, right? If PDF is non-zero, then probability will be obviously something. But if PDF is zero, then I can say that there is no density function here. So I will not be getting any sample from here to here. You're getting my point? If you draw the samples from this distribution, you will be getting all the points from in between A to B. Now, uniform distribution says that that's okay. I mean, in between A to B, that's okay. But uniform distribution says that there's an equal probability that you will be getting something in this interval. Let's suppose this interval is having a length of 1. Then let's suppose this interval is having a length of 1. Then equal number of points will be here and here, which means these lengths, if length is 1, then the number of points in this length is same as any length 1. Which means if let's suppose you are getting some number of points, maybe let's suppose 100 points here, then you will be getting 100 points here also. Which means if length is same, then the number of data points are also same. It says that probability is directly proportional to length of the interval. So in the uniform distribution, I say that there is a, like for the PDF, this is the equal PDF for every value. I mean, from in between this A to B, the PDF is equal, which is C. Now then I said, like for any interval, whether it is from maybe from 2 to 3 or from 6 to 7, does not matter. It depends on the length of the interval. If the length of interval is same, then the probability is also same. I will prove it in a while. So there are one or two things that we need to see, that what is the value of this C, and another thing we need to see. First thing, what is the value of this C? Another thing we need to see is this, like why I'm saying that probability is directly proportional to length of interval. Okay. So let's just do step by step. So first is like, what is the value of C? How to calculate the value of C? It is easy. So you need to basically make this PDF, which is from -infinity to infinity, fx, which is same as in this case from A to B, fx, it should be 1. And what is the fx here? If from A to B, it is C. So you will say from A to B, this C dx, I mean fx dx basically, fx dx, it is 1. And then it means C into x, A to B is 1. And then from here, if we want to find out the value of C, it is coming out to be B minus A, right? It is B minus A. I hope that is okay to everyone. Okay. Okay. Now C is coming out to B minus A. So how to calculate the C? You can just integrate this from A to B, and that is 1. Which means that this height, I mean this height is basically C, which I was interested, because this is same from A to B. This is the plot of PDF, which is same. Now this height is coming out to be 1 upon B minus A. That's okay. I mean, this is one of the way to calculate this height, but another way could be like this, since it is just a rectangle, you can say you want to calculate this height, which is C. Okay, since this is just a rectangle, and the integration means the area of the rectangle. So which means height into width. What is the height? C. What is the width? B minus A. C into B minus A should be 1, and then from here you can calculate C, which is 1 upon B minus A. Okay, I mean, in case of uniform, this calculation becomes very easy. You do not need to actually integrate. You can just deal in the rectangle. Okay, in case of uniform, because this is just a rectangle, so integration is just finding out the area, and we know the area is height into width. So in case of rectangle, the calculations, sorry, in case of uniform, the calculations are actually extremely easy. Okay, I hope everyone got this, that how to calculate the C. Now I said, like, there are two things I have stated here. One is that what is the value of C. Now I know the value of C, which is 1 upon B minus A. Okay. Now another thing I said, like the probability of any interval, like being in any interval, basically is the length of the interval only. Let's just see this. I mean, why it is true. and why it is even making any sense. Suppose this is your PDF, and let's consider another PDF, which is let's suppose something like this. Now tell me, here in this PDF, let's suppose this is 3, this is 6, this is 9. In this PDF, the probability being 3 to 6 is greater, or 6 to 9 is greater. Obviously, 3 to 6 is greater. I mean, the area is greater, right? This area seems to be greater, so 3 to 6 is greater. But here, let's suppose I have 3 to 6 or some interval here. This is 3 to 6. Here, maybe 6 to 9. Here, tell me 3 to 6 is greater or 6 to 9 is greater? Same, right? What about 3 to 6 and 6 to 10? Let's suppose this is 6 to 10. Which one is greater? 3 to 6 or 6 to 10? This 3 to 6 is greater or 6 to 10 is greater? This one. Is this same? No, it cannot be same. How it could be same? 6 to 10 should be greater, right? I mean, you just calculate the area. Here, this is 3 into, what is the area here? This is 3 into C. I mean, this area is 3C. This area is 4C. So obviously, this 4C is greater, right? So this 4C is greater, like there is no doubt in this. So basically, it depends on the length only. I mean, if the length is 3, then it is 3C. It could be anywhere, okay? If length is 3C, if length is 3, then this 3 length could be anywhere. Let me go to the next page. Suppose this is the PDF you have, and then if I ask you what is the probability being in any interval, let's suppose 3 to 6 or any interval, then you will say, let's suppose this is 3, this is 6. The probability that X being in between 3 to 6, then you will say this is 3C. Because it is basically the area of this, which is 3 into C. I mean, if you want, I can calculate it mathematically also. Let's suppose this is 3 to 6 and fx dx. That's what we want to find out, right? And what is this? Can anyone calculate this? This fx is, I think, C, which is 1 upon b minus a. So this is 1 upon b minus a dx from 3 to 6. I mean, let's just calculate, let's just take it as C, okay? I mean, I can put the value of C, which is 1 upon b minus a, but let's just take it as C. So it will be Cx, and then it is basically 3 to 6. If you calculate it, it will be 3C only. I mean, actually, I do not want to use the integration in case of uniform, because if life is simple, then why to make it complicated? Do you want to use integration, or you just want to use height into width? Obviously, height into width, right? I mean, why to use integration if you have the directly height into width? So whenever you want to find any probability in case of uniform, just apply height into width. Okay, don't do integration. I mean, you can do integration. That's not a problem. But height into width is actually very easy to do it. So one thing is that if I just ask you that what is the probability in between 3 to 6, you will say this is the probability. Now, other thing is that if I ask you what is the probability in between 6 to 9, then you will say in between 6 to 9, since this width is 3, height is C only, so you will say the probability of being 6 to 9 is 3C only, right? 3C. Now tell me what is the probability in between 6 to 10. 6 to 10. You will say it is 4C actually, right? It is because the height of the width is 4, so that's why it is 4C. So basically, it depends on the length of the interval. If the length of the interval is 3, does not matter. But where is this 3? Is this 3 is here, this 3 is here, does not matter. Right? So the probability of that interval, probability of any interval, is basically probability of any interval, you can say, is length of the interval into C. Basically, you can say it is directly proportional to length of interval. Okay, it is directly proportional to length of interval. So probability of any interval is directly proportional to length of interval. That's why I have written there that probability of any probability of any interval. Basically, I should be writing here probability of any interval is directly proportional to the length of an interval. Yes, height is constant. Yes, that's nice observation. That height is constant. Height is same for everyone. Okay. ठीक है, ये आ गया सबको समझ. Now, let's just calculate the probability in between C to D. Can you do it? Do you want to use integration, or you just want to use the normal thing? I think the normal rectangle thing should be okay. Height is 1 upon b minus a, and length is d minus c. So it is d minus c into 1 upon b minus a. So it is d minus c upon b minus a. it will not be plus one. Actually, here this the point probabilities doesn't matter. It will not be plus one and minus one. Okay, so the point probabilities doesn't matter. This D is not having any significance in its own. I mean D, and then this the next point will be just lesser than D. So the point probabilities here are 0. Okay, so length of the interval and the number of points in the interval are actually different thing. If I just ask you what is this length of the interval, then you will say the length is just one. The length of this interval is just one. Similarly, if I ask you length of this interval is 2, right? And if I ask you the number of points in between 1 to 3, including the 1 to 3, then these are 3, right? Number of points in the interval, like including 1 to 3, is 3, but the length of the interval is just 2. Okay. Anyway, I hope it is fine to everyone. So it is D minus C only. It will not be plus 1 because the length of the interval is different and the number of points are different. Okay, we are not calculating the number of points here. We are calculating just the length. Okay. So here also you can see the length is it like the probability of this interval depends on the length of this interval. If the length of this interval D minus C, then it depends on D minus C. Okay, it does not matter where the C and D are located, which means if this is 3, this is 6, then this will be 3. If C is 3 and maybe this is 7, D is 7, then this will be 4, something like that. So I hope you are convinced that the length, the probability is basically the directly proportional to the length of the interval. So that's why it is uniform, which means for any interval, given the length is same, it is uniform. Okay, so that's why we call it uniform. For any interval, the probability is same. I mean, if the length is same, obviously, right? If I'm being fair to them, which means if I'm having the same interval, the same the length of the interval, then the probability will also be same. Okay, the probability is coming out to be this. Okay. Now let's just calculate, or let's just solve this question. So here they have this. Let me erase this. So they are saying that X is a uniformly randomly distributed over 0, 10, which means that from 0 to 10, it is uniform distribution. Now, do they have to tell you the PDF? If they are saying that is from 0 to 10, can you calculate the PDF? Can you tell me from 0 to 10, if X is from 0 to 10, or like open interval, closed interval does not matter in case of continuous. Okay, like the continuous the point probabilities are 0 basically. So can you like this is 0 basically, can you calculate this quantity? This will be if it is C, then actually this is 1 upon B minus C, right? I mean, if you want, you can calculate it. This is 0 to 10, this is C, and then the area is 1, so thus 10 into C equal to 1. So basically it is just 1 upon 10. Okay, 1 upon 10. This is 1 upon 10. I mean, you can calculate using the area. I mean, if you want, you can use the integration, but let's avoid the integration altogether. Now they're saying that what is the probability that X is less than 3? What is the probability that X is greater than 6? What is the probability that like this? So can you calculate these three? X is less than 3. X less than 3, which means you are talking about this. So let's just do using just a rectangle thing without using the integration. So length is 3 by 10, right? It is very simple, 3 by 10. I mean, length is here 3. It is just length divided by length into this C. And what is this probability X greater than 6? Can anyone tell me very quickly? What is the length? X greater than 6. They're interested in this. Length is 4, right? So 4 by 10. I mean, if length is 4 by 10, it is very, very easy. What is the probability that this is between 3 to 8? What do you think? What is the length? Length is 5, so 5 by 10, right? Very, very easy. I mean, uniform is actually very easy. Okay. I mean, if you want, you can use the integration. Like here, just for the sake of mathematical notation, they have used the integration, but I will prefer like you use the rectangle thing directly. Okay. Integration is also fine. Rectangle is also fine. Okay. Let's just see this. Now they are saying that for the uniform probability density function described earlier, a equal to 0 and b equal to 10, fx is this. Okay, that they have just given it, but otherwise we could have calculated it, right? This is 1 upon b minus a. We could have calculated it, but that's okay. They are saying find the probability this. Can you tell me quickly what is the probability this? Tell me very quickly. 15 minus 1, which is 14 by 20, right? 14 by 20. And what is this expectation? Yeah, expectation we have not calculated till now for any continuous random variable. Let's just do it for the very first time. Expectation formula will remain same, which is minus infinity to infinity x fx dx. Okay. Earlier it was summation. Now it is integration in expectation of x, which is basically same as here. The probabilities are non-zero. This PDF is non-zero in between 0 to 20, right? 0 to 20. X fx is 14 by 20 dx. Okay, so if you calculate, it is x square by 2, and then this is 20 square by 2. Let me write first. This is x square by 2. So this is 14 by 20 into x square by 2, 0 to 20. So it will be 14 by 20 into 20 square by 2. Okay, it is 10, 140. So expectation is coming out to 140. ये आ गया सबको समझ? Now, can you see it intuitively also, like why this expectation is coming out to be 140? Let's just see this. See, this is from 0 to 20. You know, this is the PDF that is given to us. Okay. This is C. And C is given to be 1 upon 20. Okay. Sorry, this is 1 upon 20. This is not 14 upon 20. This should be 1. This fx is 1. So this is 1. This is 1. And finally, we have this 20, 20 get cancelled out. We have just 10. Right? Okay. We have 10. Yeah, 1 upon 20 is given. We have 10. So we have 10 as answer. So basically, like, I mean, from this also you can I'm like you can figure out the expectation. Expectation is basically sitting in the middle, right? If it is uniform, then it should sit in the middle, which means this is 0, 20, then this should be 10, right? On average, like you can say the expectation is 10. Anyway, like we can calculate it mathematically. Let's just do it for the longer example, which means let's suppose that in general, your range could be from A to B. Let's suppose your range is from A to B. Then let's calculate the expectation variance. Okay. So range is from A to B this time. Then can you write the PDF? Can you write the PDF? It is 1 upon B minus A. X is in between A to B. Does not matter. This equal does not matter. You put equal, you do not put equal, does not matter. Otherwise, this. Okay. Expectation is basically expectation of X is x fx dx, and in this case it is from A to B, which is A to B 1 upon B minus A x, which is actually x square A to B, and then 1 upon B minus A. If you calculate it, it will be B square minus A square, and then it will be just, I mean, B square minus A square upon B minus A. This by 2 is remaining somewhere. This is fine. Yeah, x square by 2. X square by 2. So this is by 2. So it will be A plus B by 2. You can calculate the mean. It will come out to be A plus B by 2. Okay. This mean, generally we denote the mean by mu, but let's not worry about it. And the variance by the sigma. Okay. So sigma square basically. So mean or the expectation is A plus B by 2. And the standard deviation, or maybe you can calculate the variance first, and then we will calculate the standard deviation. So the variance, like we do not actually need to calculate because these are the integration in these things. So we will just remember it forever. So it is x square fx dx. Expectation of x square is x square fx dx from A to B, which is basically fx is 1 upon B minus A. X square dx A to B. This is x cube by 3, and then this is b cube minus a cube by 3 into b minus a into 1 upon b minus a. Then it will be What is the formula? AQ minus BQ, A minus B into something, right? So do anyone remember the formula? I think it is B minus A. Okay, there is some formula, I do not remember exactly, but till now it is fine. This is 1 upon B minus A. I think things are good, right? Okay, this is BQ minus AQ. So basically this will be x cubed by 3 from A to B. So it should be fine, right? And then if you calculate it, it will come out to be B minus A whole square by 12. So I hope the calculations are fine. Do you see any flaw in the calculation? Yeah, seems good, right? So this is x square. Oh, sorry. Like this is not this answer. Like first you need to calculate this, then you will be calculating the variance. The variance of x will be expectation of x square minus expectation of x whole square. Right. So expectation of x square you need to put this, and then expectation of x whole square. Then it will come out to be b minus a square by 12. So anyway, we will just remember it forever. Okay, we will not calculate the expectation variance for any random variable again and again. And for especially for the continuous, you just remember it. Okay, you should not calculate it again and again. So especially for the continuous. Now I hope that is fine. Now let's just see some question. So suppose they are saying that bus is uniformly late between 2 to 10 minutes. Okay. Now how long can you expect to wait? Which means the bus could be anywhere late. So basically x is a random variable that is a uniformly distributed between 2 to 10. Now they're asking what is the expectation of x. I mean, on average, how much you should be waiting? It is a plus b by 2, which is 2 plus 10 by 2, which is just 6, right? Yeah, mu is 6. Now the second question they are asking, how long can you expect to wait? This is the first question. With what standard deviation? Which means standard deviation basically tells you that how much it is varying. So let's just first find out the variance. Variance of x is b minus a whole square by 12, which means this is 10 minus 2, 8 square by 12. 8 square by 12. Now standard deviation, which is generally represented by sigma, which is square root of 8 square by 12, which means 8 by square root of 12, which means this is, if you just calculate it, there it is coming out to be 2.31. Okay, 2.31. Now, what does this actually tell you, standard deviation? Can anyone tell me what does this standard deviation tells us? It generally tells us that we are expected to wait on average six minutes. I mean, on average, the bus will be 6 minutes late, but most probably, I mean, it is basically the 6 minutes late, but with the standard deviation of 2.31. मतलब कि हो सकता है कि प्लस माइनस 2, मतलब हो सकता है कि लाइक इफ आई जस्ट कंसीडर 2 देन हो सकता है कि 4 मिनट वेट करना पड़े, हो सकता है कि 8 मिनट वेट करना पड़े. But on average, I need to wait for 6 minutes, but with the standard deviation of 2, which means that on average I need to wait for 6 minutes, but on average with the standard deviation of 2 also, 6 minutes with the standard deviation 2, which means 6 is not the average, it will fluctuate. Sometimes the average will come out to be 4, sometimes the average will come out to be 8. A standard deviation just tells us that how much you are deviating from the mean, basically. Okay. I mean, these are some graphical things that if you know it is okay, otherwise gate will not ask it. Okay. So you will be late for the work. What is the probability of you being late? If okay, they are saying the third question is that if it is greater than 7 minutes, then you are late. Which means it could vary from 2 to 10. It could vary from 2 to 10. The timings could vary from 2 to 10. They are saying if it is greater than 7 minutes, अगर वो 7 minutes से ज़्यादा late हो जाती है बस, then you will be late for your work. Which means if you are going to office or if you are going to college, you will be late. Then what is the probability that you will be late? Which means what is the probability that your random variable will take this value? I mean, they are asking of this probability. Which means this length is 3 and 3 into what is this? 1 upon b minus a, right? 3 upon 8. 3 upon 8 आना चाहिए ना? Why you are getting 17 by 2? Let me check the answer. 0.375. Yes, 3 upon 8 is the answer, right? I mean the length upon b minus a, basically the height and width. So b minus a is basically your height, and this is 3. 3 into this. I hope you got it. See, this is 7, let's suppose 7, and then this is your 8. So they're asking about this area, which is 3 into 8. Oh, sorry. What I'm saying, this is not 8, this is 1 upon 8. Yeah, 3 into 1 by 8. They are asking about this area, which is 3 into 1 by 8. Okay. I hope this question is clear to everyone. Now let's move to another random variable, which is normal distribution or normal random variable. Sometimes we also call it Gaussian distribution.